Hi students, today we are going to see matrices in applied mathematics. What is a matrix? Before going to the concept of matrix, let us show a picture. Okay. What you see in this picture? It is the compression of the data of a class of students which contains both boys and girls, and it gives the data about their color of the eyes. Here we are given with data comprising of boys and girls who is having different colors of eyes. Okay. So, this gives a compact picture of the data. So, here the data are arranged in rows and columns. Each row represents how many boys have that eye color, and each column represents a different eye color. So, the data are arranged in order, row and column. Okay. And similarly, you can see the another one. Okay. So, this is the introduction for a matrix. Where we are going to apply the concept of matrices, we must know. Before we learn, we should know where we are going to use the concept of matrices. Matrices are applied in linear programming and optimization, but how we are going to use that we will be learning, and then we try to apply that. Okay. Linear programming and optimization, and input output analysis, data organization and analysis, Markov chains, solving system of linear equations. We know how to solve a linear equation in 2 variables and 3 variables by elimination method, but if you are going to use matrices, it will be very simple to solve the system of linear equations. We might have a situation where we cannot solve the equation by our known method, elimination method and substitution method. Next, forecasting and simulations, cost and revenue calculation. So, in this area we are going to apply the concept of matrices. Okay. Now, let us come to the definition of a matrix. What is a matrix? A matrix is a rectangular arrangement of m into n elements. It is going to contain mn elements in the form of an ordered set of m horizontal arrangement. Each horizontal element has order set of n elements. So, a matrix is a rectangular array of numbers arranged in horizontal as well as vertical. Okay. Horizontal arrangement is called as row and vertical arrangement is called column. So, to understand the concept of matrix, we should know the technical terms involved in describing the matrix. A matrix is a rectangular arrangement of elements. Okay. And what is a row? Row is horizontal arrangement of elements. Column, column is nothing but vertical arrangement of elements, is called as column. Okay. Now, with this introduction of row and column, we define what is the order of a matrix. Order of a matrix is defined as the number of rows and number of columns it has. Okay. What is the how many rows the matrix is going to have and how many columns the matrix is going to have will describe the order of the matrix. Order of matrix is defined as number of rows by number of columns. If I say a matrix has five rows and four columns, then order is 5 by 4, and you might have noted that when we write 5 into 4, but when we say it should be read as 5 by 4. So, the first number denote number of column, number of rows, second one represent number of columns. In general, the order of matrix is denoted by M by N, which means matrix A as M rows and N columns. Okay. Usually matrices are denoted with the capital letters. Usually matrices are denoted by capital letters. So, capital A, capital B, capital C, capital D and so on. Elements are denoted by small letters. Okay. And elements are enclosed within the parenthesis. Okay. That parenthesis can be ordinary bracket or square bracket. Okay. So, the general structure of a matrix will be A is equal to A, B, C, D, E, F, G, H, I, J, K, L. I, J, K, L. Okay. Now, which is row and which is column? The horizontal arrangement are called as rows. This is the first row, and This is called as second row, and this is called as third row. So, horizontal arrangement, this is called as horizontal arrangement. So, these elements present in this horizontal way is called as row elements, row. So, this is R1, this is R2, this is R3. Okay. And vertical arrangement is called as column. Vertical arrangement is called as column. So, these are going to be, this is first column, this is first column, this is going to be your second column, this is going to be your third column, this is going to be your fourth column. So, the vertical arrangement are called as column. So, this is C1, C2, C3, C4. So, if a matrix has 3 rows and 4 columns, then the matrix A is written as A suffix 3 by 4, which means it is going to have 3 rows and 4 columns. How to represent element in a matrix? Representation of element in a matrix. The elements in the matrix are denoted by small letters A, I, J. A, I, J. I represents row number, J represent column number. So, if you want to write the elements in the general format, so if you have a 3 by 3 matrix, the elements in the matrix will be written as A11, A12, A13, A21, A22, A23, A31, A32, A33. Now, tell me why this number is written as A11. The number is written with A11 because it is present in the first row, first column. It is present in the first row, first column. This is R1, R2, R3. Horizontal arrangement are called as row. Vertical arrangements are called as column. C1, C2, C3. Now, why this is written as A13? Because it is present in the first row, third column. How about this one A31? A31 is present in the third row, first column. So, if I write A33, then that element is present in the third row, third column of the matrix. So, basically, to study about matrix, we must know what is a row, what is a column, and what is the order of a matrix. Okay. If you have understood these 3 definitions of row, which is nothing but horizontal arrangement, column, vertical arrangement of the elements, and order. Order is nothing but the number of rows and the number of columns present in the matrix. So, if a matrix is going to have m number of rows and n number of columns, then the order is nothing but m by n. Based on the order of the matrix, we classify the matrices into different types. Okay, now we are moving into the types of matrices. Types of matrices. Okay, first one, row matrix. Row matrix. What do you mean by row matrix? By basic definition, it is going to have only one row. Then it is called as a row matrix. A matrix which has only one row. It can have any number of columns. So, a row matrix is basically a matrix which contains only one row. If a matrix has only one row, then it is called as row matrix. And how many columns it can have? It can have any number of columns. A row matrix can have any number of columns. Okay. Now, what is the general form of a row matrix? The general form row matrix will be A is equal to, it is going to have only one row. So, it is A11, A12, A13, etc. A1n. What is the general order of a row matrix? The order of a row matrix will be of the form A 1 by n. Is it clear? It will have only one row. It will have only one row, but it can have any number of columns. That's why the general order of the matrix is nothing but 1 by n. Suppose if I say A is a matrix of order 1 by 3, then how many elements this matrix will have? It is going to have one row, but it is going to have 3 columns. So, A is equal to A11, A12, A13. So, it is going to have only one row and it is going to have 3 columns. So, the order of the matrix is 1 by 3. So, this is the first type of matrix, row matrix. The second one, obviously, column matrix. What is a column matrix? After learning row matrix, it is very easy for you to define what is a column matrix. If a matrix has only one column, then it is called column matrix. So, the column matrix, how many rows it can have? It can have any number of rows. There is no restriction in number of rows, it can have any number of rows. But if it is going to have only one column, then it is going to be a column matrix. Okay. A column matrix can have any number of rows. General form of a column matrix will be B is equal to A11, A21, then AM1. The order of the column matrix is of the form M by 1. Okay, it can have any number of rows, but it will have only one column. So the second number will be 1 only. Okay, so in a row matrix we will have one row, it can have any number of columns. For column matrix it can have any number of rows, but it will have only one column. Next we move on to square matrix. Square. So this word itself will give you the idea. What is a square matrix? Now we define what is a square matrix. How we are going to define the square matrix? Square. Basically a square will have all the sides are equal. For a square all the sides are equal. Is it clear? Now for matrix, how we are going to define? A matrix having equal number of rows and column is called as square matrix. That is, number of rows should be equal to number of columns. So the general form of a square matrix will be A n by n. For example, if you take A 2 by 2, it is going to have 2 rows and 2 columns. So number of rows is equal to number of columns. So we get A11, A12, A21, A22. So this is a matrix which is going to have 2 rows and 2 columns. Since it is having equal number of rows and equal number of columns, it is called as a square matrix. Suppose if we take another matrix B equal to B11, B12, B13, B21, B22, B23, B31, B32, B33. Now what is the order of this matrix? Order of this matrix is 3 by 3. Why it is 3 by 3? Because it is going to have 3 rows and 3 columns. Since number of rows is equal to number of columns, it is going to be a square matrix. Next we move on to diagonal matrix. Before we define diagonal matrix, let us define diagonal elements. Okay, what do you mean by diagonal elements? In a square matrix, it should be a square matrix. If it is a square matrix, then only we can speak about the diagonal elements. Okay. the elements which have same row and column number are called diagonal elements. That is, diagonal elements are nothing but A I j, where I should be equal to j. I and j number should be same. Is it clear? For example, if I am going to have a square matrix of order 2 by 2, A11, A12, A21, A22. Here we are having 4 elements. The 4 elements are A11, A12, A21, A22. Okay. Now, which are diagonal elements? The diagonal elements are nothing but the numbers which have same row number and column number. So, A11, A22 are called diagonal elements. Okay. Suppose if I am going to have another matrix B11, B12, B13, B21, B22, B23, B31, B32, B33. Now tell me how many rows and how many columns this matrix have? This matrix have 3 rows and 3 columns. So naturally it becomes a square matrix. Now tell me which are all the diagonal elements? The diagonal elements are the elements which will have same row number and column number. Okay. The elements which are present in the same row number and column number are called as diagonal elements. Now, which number have the same row number and column number? B11. Okay, it is going to be present in the first row, first column. B22, second row, second column. B33. So, these 3 elements are called as diagonal elements, and if you want to be very specific, it will be called as main diagonal elements. This will be called as main diagonal elements. Okay. So, main diagonal elements are the elements with A I j, where I and j are equal. Okay. The row number and column number must be same. Then the elements are called as diagonal elements. Now, after defining the diagonal elements, we move on to defining the diagonal matrix. What do you mean by a diagonal matrix? Now, we are going to define what is a diagonal matrix. A square matrix in which all the elements other than leading diagonal elements are 0. So, we are going to have a square matrix. In that square matrix, except the leading diagonal elements, all the elements are going to be 0. Okay. A square matrix in which all the elements other than the leading diagonal elements non-zero, other elements are going to be 0. For example, A is equal to 1, 0, 0, 4. Basically, it should be a square matrix. It should be a square matrix. In that square matrix, except the diagonal elements 1 and 4, all the elements are 0. So, in that case, we call this matrix as a diagonal matrix of order 2 by 2. Let us consider another example. B is equal to root 3, 0, 0, 0, 5, 0, 0, 0, minus 11. This is a matrix of order 3 by 3. In this matrix, except the diagonal elements, other elements are going to be 0. So, this is termed as a diagonal matrix. Let us consider another example. Okay. Now, tell me whether this is a diagonal matrix or not. This is a diagonal matrix because 0 is also a number, but the main diagonal elements, apart from the main diagonal elements, all other elements are going to be 0. So, this is going to be a diagonal matrix. What happens when this 5 and 9 are also going to be 0? Then it will be given a special name called null matrix or 0 matrix, that we will discuss separately. Okay. Next, we move on to scalar matrix. If in a diagonal matrix, all the leading diagonal elements are equal but not equal to 0. Then it is called scalar matrix. So, it should be a diagonal matrix. So, basically to be a diagonal matrix, it should be a square matrix. So, if you want to know about a thorough knowledge of scalar matrix, first we must know about square matrix. It should be a square matrix. In that square matrix, except for the diagonal elements, all the elements are going to be 0, and the non-zero elements which present in the diagonal are going to be equal. They are going to be the same. Then it is called a scalar matrix. Okay. For example, A is equal to 5, 0, 0, 5. This is called scalar matrix because the diagonal elements are identical. Now, say another example. Root 3, 0, 0, 0, root 3, 0, 0, 0, root 3. So, this is a square matrix of order 3 by 3, and except the diagonal elements, all the elements are going to be, this is your leading diagonal elements, except these diagonal elements, all the elements are going to be 0, and moreover the diagonal elements are going to be same, identical, they are going to be equal. So, this is called as a scalar matrix. Okay. Now, if these three elements root 3, root 3, root 3 are going to be 0, in the place of root 3, if we are going to have 0, then we will be calling that matrix as null matrix. Okay, we will be calling that matrix as a null matrix. Okay. Minus 5, 0, 0, 0, minus 5, 0, 0, 0, minus 5. This is also an example for a scalar matrix. Okay. So, we have learned square matrix, then diagonal matrix, scalar matrix. Now, we are going to define identity matrix or unit matrix. Identity matrix or unit matrix. And identity matrix or unit matrix are denoted by I suffix with the order. Okay. Now, what is the identity matrix? A scalar matrix in which the leading diagonal elements are equal to 1. Okay. So, a scalar matrix in which the leading diagonal elements are going to be equal to 1, then that matrix is called as identity matrix. Okay. So, for scalar matrix, it should be, first of all, it should be a square matrix, then it should be a diagonal matrix, then it should be a scalar matrix, and in the scalar matrix, if the leading diagonal elements are going to be equal to 1, then it is called as identity matrix. So, we write identity matrix as I suffix with the order. So, I2. I2 means identity matrix of order 2 by 2. So, the elements will be 1, 0, 0, 1. This is the identity matrix of order 2 by 2. What about I3? I3 will be identity matrix of order 3 by 3. So, 3 rows and 3 columns will be present. We will have 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Now, we come to the exceptional case of the matrix, null matrix. Null matrix, a matrix in which all the elements are 0. Okay. A matrix which is going to have all the entries or the elements to be equal to 0, then it is called as null matrix. All the elements or entries equal to 0 is called zero matrix or null matrix. It is denoted by capital O. Okay, capital O. Is it clear? It need not be a square matrix. It can be of any order. For a null matrix, it need not be a square matrix. It can be of any order. Okay. So we write O is equal to 0, 0, 0, 0, 0, 0. This is going to have 2 rows and 3 columns. So this is 2 by 3. 2 by 3. We can write O is equal to 0, 0, 0, 0, 0, 0. This is going to have 3 rows and 2 columns. So this is 3 by 2. Okay. What is a null matrix? A null matrix is a matrix in which all the entries are going to be 0. Now we are going to see special cases of matrices. Okay. Now we are going to consider upper triangular matrix. Upper triangular matrix. Okay. It should be a square matrix. It should be a square matrix in which Aij should be equal to 0 for I greater than j. Aij should be equal to 0 for I greater than j. That is, for example, if you are having a matrix A, 3 by 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. In this case, Aij should be equal to 0 whenever I is greater than j. Here, 2 is greater than 1, 3 is greater than 1, 3 is greater than 2. So these 3 elements are going to be 0. So example for an upper triangle matrix will be A11, A12, A13, 0, A22, A23, 0, 0, A33. So the elements which are present above the main diagonal will be non-zero. Elements or the entries present above the leading diagonal or main diagonal. Main diagonal elements are non-zero. Then it is called as upper triangular matrix. So if you are going to have upper triangular, naturally we are going to consider lower triangular matrix. What is lower triangular matrix? It should be a square matrix in which Aij is equal to 0 when I is less than j. When I is less than j. In other words, elements present below the main diagonal are non-zero. So for example, we can have B is equal to, consider a 3 by 3 matrix because it should be a square matrix. So it is A11, 0, 0, A21, A22, 0, A31, A32, A33. So, the elements which are present below the main diagonal are non-zero. Okay. So, it is called as lower triangular matrix. Now, we are going to see equality of matrices. When we can compare two matrices, I am having two matrices, matrix A and matrix B. Can I compare the two matrices for equality? When I say these two matrices are equal, two matrices are said to be equal if they are of same order and their corresponding elements are also same. So, two conditions it has to satisfy. So, A equal to B implies order of the matrices are same, or in other words, both the matrices are of same order. And second one, corresponding elements are also same. Is it clear? Okay. Now, what do you mean by order of the matrices are same? Suppose if A is a matrix of order 3 by 2, that is matrix A is going to have 3 rows and 2 columns. Then we can compare only when B is also of the same order 3 by 2. Is it clear? So, A is going to have the entries A11, A12, A21, A22, A31, A32. B is going to have the entries B11, B12, B21, B22, B31, B32. Okay. Now, can we compare these two matrices? Yes, we can. Why? This is a matrix of order 3 by 2, B is also a matrix of order 3 by 2. I can compare, but whether they are equal or not. When they will be equal? A is equal to B when first row first column element is equal to first row first column element of the matrix B. That is A11 should be equal to B11. Not only that particular element, all the elements, corresponding elements must be same or equal. That is A12 should be equal to B12. and A21 should be equal to B21. A22 should be equal to B22. A31 is equal to B31. A32 should be equal to B32. So, their corresponding elements must be equal. A12 should be equal to B12. Is it clear? A21 should be equal to B21. A22 should be equal to B22. A31 should be equal to B31. A32 should be equal to B32. If their corresponding elements are equal and the matrices are going to be of same order, then we say that two matrices are equal. Okay. Now we are going to see negative matrix of A. Negative matrix of A. Negative matrix of A is obtained by multiplying all the elements of matrix A by -1, and it is denoted by -A, negative matrix of A. Suppose if I have a matrix A with A, B, C, D, the negative matrix of A is denoted by -A. How we are going to obtain? We multiply all the elements of matrix A with minus symbol, that is -A, -B, -C, -D. Okay. If I am having a matrix B which is equal to 5, 3, -1, 4, 6, 8, 9, -7, 4. Then what is negative matrix of B? It is denoted by -B. It is -5, -3, +1, -4, -6, -8, -9, +7, -4. How we got this matrix negative -B? We multiply all the entries, we multiply all the elements of matrix B with -1. Is it clear? And the negative matrix will be used in subtraction of matrices. Suppose if I am having A minus B, then it will be nothing but A added with the negative matrix of B. So, in this concept it is very useful to know about the negative matrix. Okay. Suppose if I am having 2A minus C, okay. In that case, we perform the addition 2A plus of minus C. So, instead of subtraction, we add 2A with the negative matrix. Is it clear? So far we have seen the different types of matrices. What are the different types of matrices we have seen? First one, row matrix, then column matrix, then square matrix. After square matrix, diagonal matrix, scalar matrix, unit matrix or identity matrix, then upper triangular matrix, lower triangular matrix, null matrix and negative matrix. Is it clear? And one special case is there, rectangular matrix. A matrix which is not a square matrix will be termed as a rectangular matrix. Okay? A matrix which do not have same number of rows and columns, then that matrix will be termed as rectangular matrix. If number of rows is not equal to number of columns, then that matrix is termed as rectangular matrix. So, from the concepts or the definitions what we have learnt, let us do few problems. Now, tell me what is the order of this matrix? How to find the order of the matrix? First, to find the order of the matrix, we must count how many rows it is going to have. How many rows it is going to have. Horizontal arrangement are called as row. So, this is first row, second row, third row. So, it is going to have 3 rows. And vertical arrangement is called as columns. So, first column, second column, third column, fourth column. So, how many columns it is going to have? 4 columns. So, the order is 3 by 4. Is it clear? Is there any relationship between the number of elements present and the order? Yes, naturally. The number of elements present in a matrix is equal to the product of the row number of rows into number of columns. That is, here we are having 3 rows and 4 columns. Multiply. So, 3 into 4 is equal to 12. So, how many elements are going to be there in this matrix? In this matrix, we are going to have 12 elements. Suppose if a matrix is going to have 5 rows and 4 columns, how many elements that matrix will have? Yes, exactly. It is going to have 20 elements. It will have 20 elements. In these problems, we are going to identify the type of matrix and additionally, we are going to find the order of the matrix also. Is it clear? Let us start. The first question, A is equal to matrix with element 2 and 3. What is the type of the matrix? How to identify? How many rows it is going to be containing? It is containing only one row. And how many columns it is going to have? 2 columns. So, it is a row matrix. This is called as row matrix because it is going to have only one row. Second one, B matrix is equal to 3 minus 2, 1. Now, we are supposed to find the type of the matrix and also the order of the matrix. Now, tell me what is the type of the matrix? 3 minus 2, 1. It is going to have only one column. It is going to have only one column. Because it is going to contain only one column, it is going to be termed as column matrix. Okay. Now, to find the order of the matrix, we must count number of rows only first. How many rows it is going to have? It is going to have 3 rows and it is going to have only one column. So, the order of the matrix is 3 by 1. Although we write 3 into 1, but when we say the order, it should be 3 by 1. Okay. Now, third subdivision, C is equal to 2, 5 minus 1, 2, 4, 0. It is going to have 3 rows and 2 columns. Okay. So, it is not going to contain only one row, it is not going to contain only one column because it is going to have 3 rows and 2 columns. Okay. It is going to have 3 rows and 2 columns. Okay. So, it is not going to be a row matrix, it is not going to be a column matrix. Number of rows is not equal to number of columns. So, it is going to be rectangular matrix because number of rows not equal to number of column. Here you can have only one row present. So, it is called as row matrix. only one column. Rectangle matrix, why? Because number of rows not equal to number of columns. What is the order of the matrix? It is going to have 1, 2, 3. 3 rows it is going to have, and it is going to have 1, 2, 2 columns. So, 3 rows and 2 columns. Now, fourth subdivision, D is equal to 1, 3 minus 4. You can very well see it is going to have only one row, correct? Because it is going to have only one row, this matrix is nothing but a row matrix, which contains only one row, but how many columns it is going to have? 3 columns. So, 1 into 1 by 3, okay, 1 by 3. Now, the fifth subdivision, E is equal to 3, 4, 4, 6, 3, 4, 4, 6. Now, count number of rows, 1, 2. So, 2 rows, 1, 2, 2 columns. So, what is the type of the matrix? It is going to be a square matrix. Any specialties about this matrix? Nothing. Okay. All the elements are present. So, it is a square matrix. That is it, of order 2 by 2. Number of rows is equal to number of columns. Now, see this one. P is equal to 0 minus 4, 3, 1, 0 minus 7, 2, 2, 0. Is it clear? Now, we see that it is going to have one row, second row, third row. So, it is going to be 3 rows. First column, second column, third column. So, number of rows is equal to number of column. Therefore, it is a square matrix. Okay. In this square matrix, any specialty is there? Nothing is there. Here the leading diagonal elements are 0. If leading diagonal elements are not 0, other elements are 0, then we call that as diagonal matrix. But this is not given a special name. It is just a square matrix. Next one, 0, 0, 0, 0. Okay. So, very easy to see that all the elements are going to be 0. So, first row, second row. So, it is 2 rows and 2 columns. So, 2 by 2. Since all the elements are 0, this is called as null matrix. This is called as null matrix. Now, see the other one, R is equal to 0, 0, 0, 0, 0, 0. Here also all the elements are going to be 0. So, this also will be given the name null matrix. Now, how many rows it is going to have? 2 rows, and how many columns? 3 columns. So, 2 by 3. Now, see the next one, 1, 0, 0, 0, 1, 0, 0, 0, 1. So, it is going to have 3 rows and it is going to have 3 columns. So, the order of the matrix is 3 by 3. Is it clear? Now, the main diagonal elements are equal and it is equal to 1 naturally. Okay. So, this is called as identity matrix. This is called as identity matrix or unit matrix. Okay. Now, we move on to next question. Now, in the previous case we had 1, but now we are having 2, 2, 2, correct? So, this is a square matrix. We can very well see that it is going to have 3 rows and 3 columns. So, number of rows is equal to number of columns. So, it is basically a square matrix. Okay. And except the leading diagonal elements, all the elements are 0. So, it is a diagonal matrix. and all the diagonal elements are same. So, it is a scalar matrix. Now, we are having three options, one is square matrix, the other one is diagonal matrix, the next one is scalar matrix. But the apt one is, it is a scalar matrix, that is the correct answer. Maybe it may be a square matrix, maybe it may be a diagonal matrix, but since all the diagonal elements are equal, we must call this matrix as scalar matrix only. We are not supposed to say this as square matrix or diagonal matrix. Okay. Now, come to the last question, 1 0 0 0 minus 2 0 0 0 3. Now, here also it is going to have equal number of rows and columns. So, it is 3 by 3. Okay. So, it is a square matrix. In that square matrix, except the diagonal elements, this 1 minus 2 3, apart from these 3 elements, all other elements are going to be 0. So, what is the name of this matrix? It is nothing but diagonal matrix. Okay. So, in this session we learnt about what is a matrix, how the matrices are denoted, how the elements are given names, what is a row, what is a column, what is a diagonal element, and the different types of matrices like row matrix, column matrix, diagonal matrix, square matrix, scalar matrix, identity matrix, null matrix, negative matrix. Okay. And we have seen few problems in identifying the types of matrices. Okay, children. In the next session, we will study about addition of matrices, subtraction of matrices, multiplication of matrices. Thank you, students.